Well, good evening, everyone, and welcome. For those who don't know me, my name is Mark Gillette, and I'm a NASA JPL Solar System Ambassador. I'd like to welcome some of the participating libraries from around the country, 10 different, 10 different states. I'd like to welcome patrons from the Winfield Library in Illinois, the S.W. Smith Memorial Public Library in Pennsylvania, the Bangor Public Library in Pennsylvania, the Cooper Siegel Community Library in Pennsylvania, the Polk County Library Cooperative in Florida, the Gates Public Library in New York, the Prairie Trails Public Library District in Illinois, the Prince George's County Memorial Library System in Maryland, the Wilhelmina Public Library in Oregon, the Lake Dallas Public Library in Texas, the Technology Engagement Center, Rutherford County Library System in Tennessee, the Solano County Library in California, the Cudahy Family Library in Wisconsin, and last but not least, the Moores Memorial Library in Pennsylvania. So welcome so much. For those who have spent some time with me in the past, you know a little bit about me, but for those who are new, I'd like to tell you a little bit about who I am. So as I mentioned earlier, my name is Mark Gillette, and I'm a native of Central Florida. I live not far from Orlando, actually near the Walt Disney World Resort. My full-time job, I am a professor of sociology at Valencia College in Orlando. I've been teaching sociology courses there for about 25 years. When I'm not busy teaching sociology courses, I have a few hobbies. One of my hobbies is traveling, and I've been very fortunate to have traveled to all 50 U.S. states, all 7 continents, and I'm up to about 60 countries globally around the world. My other passion is space, anything to do with the universe and astronomy. And so over the last couple years, I was chosen by the Jet Propulsion Laboratory in Pasadena, California, to be what's called a Solar System Ambassador. And that is a volunteer program that's offered to the public for NASA. So I do want to stress to you that I'm not a paid employee of NASA. I am a volunteer, and I don't have all of the answers to the questions that you might come up with tonight, but what I will tell you is that if I don't know what the answer is, I will flat out tell you that I don't know it. I won't make up an answer, okay? If you wouldn't mind doing something for me, I would highly appreciate it, and that is you should see a text box available on the device that you're watching this live event on. If you wouldn't mind doing so, in the text box, the chat box, if you could please tell me 2 things: where you live and how you heard about tonight's event. I would highly appreciate it. As we go on through tonight's program, if you have any questions that you would like me to answer, please put those in the chat box as we go along, and periodically I will kind of look over to my side, check my tablet to see if there are any questions that are coming up. So that way we can make this as interactive as possible. All right, I have a lot of stuff that I'd like to present to you tonight. So I'd like to go ahead for us to get started. I would ask that if you have not subscribed to my YouTube channel, please consider doing so. In addition, if you can turn on notifications for my YouTube channel, you will be alerted of any future NASA events that I will be hosting. I do them on a monthly basis, and I put small ads up on my YouTube channel so that you are aware of what the dates and the times are and what the presentations will be about. And so let me tell you about my next 3 upcoming presentations, YouTube live events. On Sunday, October the 25th at 8 p.m. Eastern Time, I'm going to be doing a presentation entitled Moons of Our Solar System. On Sunday, November the 22nd at 8 p.m. Eastern Time, these are all Eastern Time, I'm going to be doing a presentation about galaxies, and I've titled that one Galaxy Quest. And to wrap up the year, on December the 20th at 8 p.m. Eastern Time, I'm going to be doing a presentation about rockets. I've entitled that 3, 2, 1 Liftoff. All right, so I hope that you can join me for one or more of these events. For those who have been joining me now for a few months, I've been doing my presentations during the week, and so I'm going to try something different. I'm going to move them to Sunday evenings. I'm also going to make it a little bit later to try to accommodate people in different time zones, especially those on the West Coast, because when I'm doing them earlier in the evening, it's may not work very well for people that that live in the on the West Coast. So I'm going to try a little bit different. I hope Sunday nights work for all of you, and I hope that you will come back and join me. All right. So here's tonight's agenda. I'm going to define what a planet is. I'm going to take you from Mercury to Neptune using NASA Eyes and some new software that I've recently learned about called OpenSpace. For those who have been with me before, I've talked about NASA Eyes, so I'm going to share some more about NASA Eyes and show you OpenSpace. At the very end of tonight's program, I do want to mention exoplanets, a very exciting field within astronomy today. And then we'll have hopefully a little time for Q&A. Over on the right-hand side of your screen, you will see a picture, an image of the Sombrero Galaxy, M104. The Sombrero Galaxy is about 31 million light years from Earth. This is a picture that I've taken. Actually, it's 90 60-second exposure pictures all merged, or what we call stacked together, to bring out the light. And so that's a picture that I've taken. I think I took that about 2 to 3 months ago. So not NASA quality, as I often say, but I'm proud of it because it's something that I've actually done. All right. So lots of neat things to talk about tonight, lots of neat software to show you. Let's go ahead and get started. The International Astronomical Union, the IAU, defines a planet, and this was back in 1996, as a celestial body that A, has sufficient mass for its self-gravity to overcome rigid body forces so that it assumes a hydrostatic equilibrium, i.e. round shape. So basically that first part is saying that they want to define a planet as a bunch of dust and gas that's come together, it's formed somewhat in a round shape. And B is in orbit around a star and is neither a star itself nor the satellite of another planet, that is, a moon. Okay? And C, it must have cleared the neighborhood around its orbit. I will not be spending any time talking about Pluto tonight. I'm sorry. I know some people are very passionate about Pluto, but Pluto was demoted to a dwarf planet back in 1996. And let me tell you one of the reasons why it was demoted. Because it doesn't meet the criteria for C here. All right? It did not clear its path and the orbit that it takes around the sun. So actually it is what's considered a Kuiper belt object. All right, so I'm going to do a presentation on Kuiper belt objects, including Pluto, probably in my winter series sometime early next year. So stay tuned, come back and join me, and we can talk more about Pluto. Okay, so that's the official definition of a planet. Now, I mentioned earlier that a planet, in our definition, let's go back here, it says right here that it is not a star. And when we talk about Jupiter a little bit later in the presentation, I'm going to be mentioning that Jupiter, the planet Jupiter, is actually often considered a failed star. Okay? It's a failed star. And so here's kind of a chart as what happens when there's enough material that comes together, and when gravity pulls it in tight, it can start nuclear fusion. Well, Jupiter's not big enough to get that to happen. But as you see, as we move to the right here, Jupiter's mass, that's when nuclear fusion can start. So Jupiter is a failed star, and we'll come back and talk about that a little bit later. It's very easy, relatively easy, to take pictures of many of the planets in our solar system. Over on the left-hand side of your screen, you see a picture that I took of Venus early in the morning, which also had a full moon right there. And so there's Venus. I simply took this with my iPhone, just held it up to the window and clicked it. So it was relatively easy to do that. Over on the right hand side of the screen, you will see a picture that I took of Jupiter and its 4 Galatian moons, as it's called. Now this photo was taken with a telescope and a relatively inexpensive camera. All right, so for a lot of the planets, you can get pictures on your own without a lot of work. Okay, I'm going to look at the chat box here. All right. Is anyone hearing any feedback in the audio system at all? Can you let me know if you're hearing any feedback? Is anyone hearing any feedback in the audio system at all? Can you let me know if you're hearing any feedback? No. Okay, very good. Thank you so much. Sounds great. All right, here's a really neat way of remembering and looking at the different planets within our solar system. So over on the left-hand side, you have our star, which we call the sun. And on the left hand here, you've got Mercury, followed by Venus, followed by Earth, followed by Mars. And these are all called the terrestrial planets. Okay? And these are all in the inner solar system. And then on the right hand, on your right hand, you'll have what's called the gas giants, Jupiter, Saturn, Uranus, and Neptune. And these are the outer solar system. All right? So what you are looking here at the top, these are the number of moons, confirmed and unconfirmed. In other words, there are still moons being detected and discovered for some of these outer planets. All right? But it's kind of a neat way of remembering the order of the planets. Okay. A little bit here about the atmospheres of the 4 terrestrial planets, Mercury, Venus, Earth, and Mars. Okay. Let you kind of look that over for a moment. Oh, I am seeing that you're hearing someone talk in the background. So let me see if I can correct that. All right. So can you hear me now? And did that noise go away? Yes. You can hear me. I hear, yes. Okay, very good. All right, so hopefully we have taken care of that, that background noise. Great, okay. All right. Now, so this is really cool. Here we're going to be looking at the rotation of each of the 8 planets. And let me go ahead and get this started. Okay, so what you're looking at, this is Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune there at the bottom. There are a couple things that I'd like you to notice while looking at this. Number one, look at how fast both Jupiter and Saturn are rotating. Over here on the left-hand side of your screen, you can see that the Earth, we all know that the Earth's day, a day on Earth, is about 24 hours. But look on Jupiter, it's only about 10 hours, and on Saturn, it's only about 10 and a half hours. So Jupiter and Saturn, significantly larger than planet Earth, are really moving and rotating very, very rapidly. That's the first thing I'd like you to notice. The second thing I'd like you to notice, it's going to be very difficult to see it here on Venus, but it's going to be a lot easier to see it here on Uranus. And that is, you will notice that the rotation is opposite the other 6 planets. Both Venus, which because Venus is moving so slow, you can see here that it's 243 days for Venus to completely rotate one time. So it's rotating very, very slowly. So that's why we really can't see much happening here. But if it was moving faster, it would be moving to the left, just like Uranus does here. Okay, so both Venus and Uranus are rotating the opposite direction than the other 6 planets are rotating. Okay, and I think this visual does a pretty good job of showing the comparative speeds of all of the other planets. Okay. Pretty cool, isn't it? Okay. So tonight I'm going to be using NASA Eyes and OpenSpace. So you might want to jot these 2 URL internet addresses down, because you will definitely probably want to go back later tonight or sometime in the future and take a look at these on your own. So you can go to eyes.nasa.gov and openspaceproject.com. Okay, NASA Eyes is a really neat, cool program that was created by JPL in Pasadena, California. OpenSpace is some software that's been created by a variety of different enterprises, including several colleges, along with NASA. So I'm going to exit here out of my PowerPoint, and I'm going to open up NASA Eyes. So again, you can go to eyes.nasa.gov. I believe now that there is a web-based version of this. There's also another version, and that's the version I have, where you download some software to your computer and then you launch it from there. So that's what I'm doing. I've downloaded some software and I'm launching it. I'm not using it directly from the web. I'm hoping that my computer is not going to freeze up on me tonight, because I'm going to be doing quite a number of different things, and I'm hoping that my computer doesn't kind of freak out on me. All right, so here's NASA Eyes. Here's our solar system. There's the inner solar system: Mercury, Venus, Earth, and Mars. And the neat thing about this is everything is exactly where it is. Okay? So this is very realistic. Earth is very close to Mars right now, and so it actually shows where everything is in relation to everything else. We can pull in the outer solar system. There's Jupiter, there's Saturn, there's Uranus over here, and Neptune is right there. All right. So that's NASA Eyes. I'm going to come back to NASA Eyes, but I want to launch OpenSpace. I didn't open this earlier because I want you to see what happens when you launch. It takes up quite a bit of space on your computer. It's actually roughly about 9 gigabytes. So it's nothing, nothing to laugh at. You definitely want to make sure that you want to do this before you download it to your computer. So let's see if I can get it to crank up here. So this is what it normally goes through. takes a while because it's loading quite a bit of data, but you will see that it's worth it because it has some incredible visuals. And again, it's called OpenSpace. So make sure that when you download it, you go to OpenSpaceProject.com. That's how you access this. Okay, again, takes a while, and I wanted to do this so that you can see that it's quite intense. So bear with me here. If for some reason my computer decides to lock up on me because I'm using NASA Eyes and OpenSpace and PowerPoint and I'm broadcasting this through YouTube, I'll try to get logged back on as soon as I can, so just kind of hang out and bear with me. I'm hoping that doesn't happen. I'm hoping everything will go smoothly. You can see it's still loading data here. Soft sun is linked to the part of the world where we live. Well, at least in Florida right now, it's dark. Still be up. It has too many clouds here. There we go. What's that? And so right now we're going to go to all right, and here is the planet Mercury. And I can spin it around so you can take a look at it. So let me tell you a little bit about the planet Mercury. It is, of course, the closest planet to the sun. On average, it's about 36 million miles from our star, the sun. Mercury has no satellites or no moons. It's approximately 1/3 the size of the Earth. It is the smallest planet, and it's actually just slightly larger than our own moon. It takes only about 88 Earth days for Mercury to orbit the sun. Keep in mind that it takes about 365 1/4 days, we'll say 365 days, for the Earth to orbit the sun. Mercury, it only takes 88 Earth days. Okay? This point, which we call the perihelion, is 29 million miles, and its furthest point, called aphelion, is roughly 43 million miles. And so I'd like to show you on NASA Eye, there is not equal space in the orbit of Mercury from any one point. Okay, so right here, it's closer to the sun when it's in this part of the orbit than it is in this part of the orbit. And that's something that's unique for Mercury, okay? If we were to look at the next planet, Venus, that we're going to talk about, Venus has a much more elliptical, evenly spaced orbit around the sun, okay? We can take a look at Mercury here with NASA Eyes, okay? And one of the neat things I can do with NASA Eyes is I can turn the light on. And so we can see all the different sides of Mercury, even if it's not currently in the sunlight. All these lines that you see here in the background, these are the lines, or the lines represent orbits of the other planets. Okay? All right. It spins very slowly on its axis, completing one rotation every 59 Earth days. All right, so keep in mind that it takes about 24 hours for the Earth to rotate on its axis. It takes Mercury 59 days to rotate on its axis. Because of the slow rotation, it is very hot on the sunlit side, roughly about 800 degrees Fahrenheit, but very cold on the dark side, about minus 300 degrees Fahrenheit. All right, and so with that small degree of tilt, that does not allow for seasons. Okay. The two inferior planets, Mercury and Venus, have what's called planetary phases. Since they have orbits around the sun that are shorter than Earth's, they exhibit the full range of phases like the moon. So if you have a telescope, you can go out different times of the year and look for Venus or Mercury, and you will see that it will not be completely round as we are looking at it in this image. It will be much like the moon, depending on our relationship to Mercury and Venus. So it has phases, and that goes again for Mercury and for Venus. Okay. NASA's Mariner 10 was the first to visit Mercury back in the night 2015. All right, so I'm going to, for a moment, and I see that someone, Mark, is saying that there's a lot of buffering. And I bet you that buffering is due to, that buffering is probably due to me trying to use all of these programs. So I think what I'm going to do is I'm going to shut down OpenSpace so that I am not utilizing all of my bandwidth on OpenSpace. And hopefully that will solve the problem with the buffering. All right, so are we good? Can someone let me know if the buffering problem has gone away? Can you see and hear me? Can you see my screen? Again, I'm wondering, someone was telling me that there was a lot of buffering. I think the buffering was due to me trying to use so many different applications and websites all at one time, and I think my computer was not able to handle it. So I decided to close. I closed down the one application, and I think I'm going to just stick with NASA Eyes. All right, very good. So that looks like it solved the problem. All right, let's go on and talk about our next destination, and we are going to go on to Venus. So I'm using NASA Eyes. Here's Venus. Go ahead and do a spin around. Has a very thick atmosphere, so we can't see the terrain from the very, very thick atmosphere. All right, so Venus is the second closest planet to the Sun. On average, it's roughly about 67 million miles from the Sun. Much like Mercury, it has no moons. It is just slightly smaller than planet Earth in size. As I mentioned earlier, it takes about 225 Earth days. It takes about 225 Earth days to orbit the Sun. Again, Earth is about 365. It is the closest planet to Earth. All right, like Mercury, as I described earlier, it does have those planetary phases. So if you go out and you look at it at different times of the year, you're not going to see the entire disk. You're going to see a portion of the disk, much like if you go out and look at the moon at different times during the month. It is one of two planets, along with Uranus, that spins in the opposite direction of the other 6 planets. And you saw that on the video that I showed you earlier. So on Venus, the sun rises in the west and sets in the east. All right, so it rotates clockwise, where the other 6 planets rotate counterclockwise. All right, I'm just seeing in the chat box here, no buffering since you turned off things. Yeah, I think I was trying to get my computer to do too many things and it just couldn't handle them, and I suspected that that would be the problem. Now I can turn on the surface here and we can see the surface of Venus by getting through the atmosphere, and that's something that NASA eyes will allow you to do. All right, and so if you go outside at night and you look up and Venus is in the sky, it is the third brightest object in the night sky, or the third brightest object in the sky behind the sun and the moon. All right. Venus has the longest day or rotation period of any planet, 243 Earth days. All right, and if you remember back to the short video that I showed you, I mentioned earlier that it really takes a long time, 243 days, 243 days for Venus to rotate one time, whereas on Earth it only takes 24 hours. All right, so it's spinning really, really slow relative to the other planets. Okay. On average, the surface temperature is between 800 and 900 degrees Fahrenheit. So it's very, very hot. It has a very thick atmosphere of mainly carbon dioxide, which has led to a runaway greenhouse effect, which has caused extreme global warming. Active volcanoes are the main source of this CO2 from Venus. All right. Venus is often considered the volcano world. 70% of Venus's surface is volcanic lava. All right. So something we don't get to see very often, what you're looking at here, the surface of Venus. Here's what we often see when we're looking at Venus through a telescope. Okay. Now, if you've been watching the news, you probably have heard in the last several weeks that an international team of researchers reported in mid-September that they detected the chemical phosphine in the atmosphere of Venus. The chemical, which is produced on Earth by bacteria, is considered a potential biosignature of life. The scientists said that they could find no possible non-biological explanation for the abundance of the chemical on Venus's in Venus's atmosphere. Although Venus is boiling at the surface, there are regions in its thick atmosphere that scientists consider to be potentially habitable. Could microbes be circulating in the atmosphere of Venus? Well, we don't know for sure, but the scientists that worked on this project not long ago are very, very excited. And so I did a presentation not long ago entitled Looking for Life Beyond Earth. And I didn't even mention Venus. I talked about Enceladus, I talked about Europa, I talked about Mars, I even talked about exoplanets and SETI, the search for extraterrestrial intelligence. But this is not something that's brand new, that there could be life in the atmosphere of Venus. It's just something that's kind of been on the back burner for quite some time. So this new research certainly will probably inspire space agencies like NASA to consider sending some type of space satellite to do some further investigation to see if there actually is life on Venus. So pretty exciting. All right, we're going to move forward and we're going to go to the planet Mars. Okay, as you can see, there's a whole lot of stuff going on here with Mars. And Mars is the most explored planet other than, of course, our own planet, planet Earth. And so Mars is the fourth closest planet from the Sun. So we've got Mercury, Venus, Earth, followed by Mars. The distance from Mars to Earth ranges from approximately 34 million miles to as far as 250 million miles. Okay? And so if we were to look at the orbit of Mars right here, okay, there's, let's see here. No, it doesn't have it doesn't actually have the orbits on. Let me go back home. There we go. Here's the orbit. Okay, you can see that right now, as I mentioned earlier, we are pretty close to Mars. All right, and so that's why back in early August, NASA launched the Mars 2020 rover, also called Perseverance, that is scheduled to land on Mars in February of next year, 2021. And the reason it was launched in August is because we need to take advantage of how close Mars currently is. That's why if you follow when they determine things are going to be launched to Mars, it generally happens about every 2 years, because what we're looking at here will happen roughly every 2 years. Okay, let's go back to Mars. All right. Mars is named by the ancient Romans for their god of war because of its reddish color. The reddish color is rich iron oxide. In other words, it's rust. One day, or what's called one sol, is 24.6 hours. So just slightly longer than an Earth day, being 24 hours. 1 year is equal to 687 Earth days. All right? Keeping in mind that on Earth it's 365. Mars's gravity is roughly about 1/3 of the planet Earth's. It's tilted at 25 degrees on axis. All right, so remember when we talked about Mercury, Mercury is only tilted at 2 degrees. Earth is tilted at 23 degrees. And Mars is tilted just slightly more at 25 degrees. And that means that there are seasons on planet Mars. It has a very thin atmosphere that's made up of carbon dioxide, nitrogen, and argon gases. It is believed that the atmosphere of Mars was blown away by solar winds due to cooling of the interior of the planet and the magnetic field shutting down about 4 billion years ago. Okay, and so that's the theory on why there is currently a very thin atmosphere on Mars. The temperatures range from a very nice 70 degrees Fahrenheit and can go as low as 225 degrees below 0 Fahrenheit. So it can be very, very cold. Dust storms are very common on Mars, which creates problems when NASA and other space agencies send landers and rovers to work on Mars, because those dust storms can put dust on the solar panels if solar panels are being used, therefore blocking out the solar panels' ability to bring in the needed sun rays to power the rover or the lander. Mars has the tallest mountain in our solar system, and let me see if I can find Olympus Mons. Let's see if I can find where it is. All right. Let me see if I can turn this around here. Give me a minute here. Where is it hiding? Okay, I guess it would help if I put it up right. All right, this is it right there. This is Olympus Mons. This is the tallest mountain in our solar system. It is 69,841 feet high. To put that in perspective, the tallest mountain on Earth is Mount Everest at about 29,029 feet. So it's about 2.5 times the height of the highest mountain on planet Earth. Okay? I'm going to go right over here to the left hand or to the right hand side and show you this canyon. This canyon is called the Valles Marineris, named after Mariner 9, NASA spacecraft that visited Mars back in the early 1970s. This canyon is roughly 2,500 miles long. Okay, so this would stretch roughly from New York to California. So if we had the Grand Canyon and we could bring it up against Mars here, the Grand Canyon would very easily fit in a very small section of this humongous canyon on Mars. It is believed that Mars once had an abundance of liquid water and had large oceans. Okay. Today there are frozen water ice caps and carbon dioxide, which is dry ice, at both the North Pole, which you can see here, and the South Pole, which you can see right there. Okay. There have been and continues to be multiple missions to study Mars. There was Mariner 4, NASA's first mission to Mars. The Mars Reconnaissance Orbiter, which you can see in orbit right there, currently going around Mars from 2006 to now. The Sojourner rover, that was the first wheeled vehicle to move on another planet, landed in 1997. Of course, we have Curiosity and Opportunity, and you can see, like, for example, here was the landing site for Opportunity. InSight, let's see if we can find InSight on here, there, right here. InSight is a lander, and it's currently on Mars, collecting research and data. And Mars 2020, which I mentioned earlier, was launched in early August. It's going to be landing in February next year, 2021, in a place called Jezero Crater. All right. So, and it has 2 moons, Phobos and Deimos. And it is believed that those 2 moons may actually be captured asteroids. All right, let's move on because I see that I am running a little long. So let's go to Jupiter. I'm going to try to speed this up a little bit. Jupiter is the 5th planet from the Sun. The distance from Earth to Jupiter ranges from approximately 365 million all the way to 601 million miles. Jupiter is by far the largest planet in our solar system. It is more than twice as massive as all the other planets combined, so it's super, super big. It orbits the Sun in 11.8 Earth years. One day is about 9.9 hours, and if you remember the video I showed you earlier, it's spinning and rotating really, really fast. Jupiter, like the next planet we will speak of, Saturn, is a gas giant, 84% hydrogen and about 14% helium. It is believed that Jupiter is a failed star, as I mentioned earlier. If there was more mass to Jupiter, a lot more mass, there may have been enough gravity and mass to start nuclear fusion, which means that Jupiter would have actually have become a star and not a planet. Okay? Jupiter's stripes, which move in alternating directions, some move to the east and some move westward, are cold, windy clouds of ammonia and water floating in an atmosphere of hydrogen and helium. Okay. Let me see if I can go ahead and get, let's see, NASA Eyes is not going to allow us to see what open space would allow us to see. Open space would allow us to see that these bands are going in opposite directions. And so NASA Eyes, unfortunately, will not allow me to show you that. So you might want to be able to take a look at that on your own. All right. Jupiter has a large magnetic field. I'm going to turn that magnetic field on for you right now. Magnetosphere. There you go. It's 10 times that of Earth. The electromagnetic radiation is very intense around Jupiter. This causes challenges for satellites studying Jupiter and/or its moons. So whenever NASA or some other space agency sends a spacecraft to Jupiter to study Jupiter, the planet, or the moons of Jupiter, it has to face all of this radiation, which creates a lot of issues and trouble for properly engineering the spacecraft to be able to handle all of this radiation. And I'll also turn on the actual radiation as well so you can see that. Okay. The magnetic field creates auroras on Jupiter, much like we have on Earth. We have the northern lights and the southern lights. I can turn on the auroras, and I'm going to turn off the magnetosphere. I'm going to turn off the radiation, and you can see right there on the planet it has auroras. Okay. All right. Juno is a NASA space probe orbiting Jupiter, and it was launched back in 2011, and we should be able to find Juno by going to spacecraft, and here's a look at Juno. Okay, so this is the spacecraft that is currently doing research around Jupiter. Okay. I'm going to pause for a moment and see if there are any questions in the chat box. There's a question from Sean. Where would you put your money on finding life in our solar system? I would probably put my money on one of the moons of Jupiter or Saturn. Those at this point seem to be the best and most hopeful place of finding, probably not little green people walking around with antennas, but finding microbial, very, very small microscopic life in the oceans of one of these planets around Saturn or Jupiter. That would be my best guess. Okay. All right. So let's now move on to Saturn. And let's find Saturn right here. All right. Of course, Saturn is well known for its rings. Let me turn it over here. There we go. Saturn is the sixth planet from the Sun. The distance from Earth to Saturn ranges from approximately 746 million up to 1 billion miles. So it's quite a distance away. It is the second largest planet in our solar system behind Jupiter. It orbits the Sun in 29 Earth years. Okay, one day is roughly 10 hours. All right, so it's moving quite fast. Saturn, like Jupiter, is a gas giant, mostly of hydrogen and helium. Saturn is tilted on its axis at about 26 degrees. All right, so keep in mind that Earth is 23.5 degrees, so Saturn is slightly more than that, which means that Saturn will have seasons like Earth does. Saturn, like Jupiter, has a bulge in the middle due to its large size and its fast rotation speed. This is something that both Jupiter and Saturn have in common. So they're not totally spherical. They have a bulge here in the middle, and that's because of their large size and how rapidly they are rotating. Saturn currently has roughly 60 known moons, including Titan and Enceladus. And right now you can see some of these moons right here. So let's back up a little bit, and you can see there is Enceladus, and there's Titan right there. So I'm going to be doing a program probably next year on talking more about life and the potential for life out in our solar system. And I'll be talking more about Enceladus and Titan. I will also be talking more about these moons in my program next month, so please make sure that you join me. All right, the average temperature on Saturn is about 285 degrees below 0 Fahrenheit. The most known feature of Saturn, of course, are the rings. It's very interesting to note that the rings are only roughly 30 to 65 feet thick. 30 to 65 feet thick, so that's not very thick at all. Okay, it's space debris, water, ice, and dust particles. Okay, that's what makes up the rings. The rings extend up to about 175 million miles from the planet itself. There are 7 separate rings named A, B, C, D, E, F, and G. Very, very creative names. And the rings move between 20 to 40,000 miles per hour. All right. Winds can blow up to 1,000 miles per hour on the planet Saturn itself. It has a strange 6-sided hexagon on its north pole, and there it is, right there. The theory is due to strong longitudinal gradient in winds, different wind speeds that are all converging on that part of the planet. NASA's Cassini-Huygens spacecraft studied Saturn from 2004 to 2017. Okay, so I see that I'm at 8:30, and so I'm going to go ahead and finish up the other 2 planets quickly. I know I'm going over, so if you have to leave me, I'm not offended, but we have 2 to go, Uranus and Neptune. Uranus is the 7th planet from the Sun. The distance from Earth to Uranus ranges from approximately 1.6 to 2 billion miles. Like Neptune, the next planet we will speak of, it is classified as an ice giant. It orbits the Sun in 84 Earth years, and one day is about 17 hours. Uranus has an atmosphere made mostly of molecular hydrogen and atomic helium with small amounts of methane. Like Venus, it rotates east to west or clockwise. So again, keep in mind that both Venus and Uranus are the oddballs in the solar system when it comes to planets because it is rotating clockwise. And you can actually see that occurring right here. Let's see if I can orient this correctly here. Okay, should be something like that. All right. The axis of rotation is tilted at about 98 degrees from vertical. So this is very, very different. Mercury only was tilted 2 degrees. Earth is about 23 degrees, but Uranus is tilted 98 degrees. So instead of it rotating like this, it's rotating like this. Okay, and it's kind of hard to see but if you look very closely, you can kind of see it rotating there. If you do NASA eyes, you can see it better than seeing it on my screen here. Okay. Like Jupiter, Saturn, and Neptune, it has a ring system. And let's see here. It's not displaying the rings here, but it does have a very faint ring system. Uranus is the first planet to be discovered with the aid of a telescope. Okay? All the other planets can be seen with the naked eye. Uranus requires a telescope. There are 27 known moons. NASA's Voyager 2 in the 1980s is the only spacecraft to visit Uranus. All right, and last but not least, let us go to Neptune. Neptune is the 8th planet from the Sun. The distance from Earth to Neptune ranges from approximately 2.7 to 2.9 billion miles. Like Uranus, it is classified as an ice giant. It orbits the Sun in about 165 Earth years, and one day is about 16 hours. The atmosphere is hydrogen, helium, methane, and ammonia. It gets its color from methane in its atmosphere. Neptune was discovered by mathematical principles and calculations and not by sight. It was discovered in 1846. Okay. It has the fastest wind speeds in the solar system at up to 1,250 miles per hour. Let me turn it. It has what's called a great dark spot, and there's the great dark spot right there. Okay, and it's a storm roughly the size of Earth. It has 14 known moons. NASA's Voyager 2 was the only spacecraft to visit Neptune in the late 1980s. All right, so let me take a look at if there are any questions that you would like to bring up. Rings are made of ice, rocks, and dust. Yes, Sean, that is absolutely correct. When will we lose contact with Voyager 2? Last time I checked, I believe they are expecting to be able to keep contact with Voyager 2 for the next four to 6 years. So hopefully we can keep contact for at least four to 6 more years with Voyager 2. Has the great dark spot been ongoing? I don't know the answer to that question. I know it's been there for a while, but I don't know if it's been there and if it was detected when it was discovered. The planet was discovered in 1840, what did I say, 1846? I'm not sure if it was seen at that time or not. How are we sure that Venus doesn't have inhabitants on the surface because of its temperature? Well, in my last presentation, Is There Life Beyond Earth, we talked about what's called extremophiles, and I know that someone brought that up in the chat earlier. Extremophiles are basically living creatures, very small, that can live in extreme conditions, hence their name, extremophiles. However, it is believed that the conditions on Venus are so extreme that they are even too extreme for extremophiles. And so that's why if life is going to be found on Venus, it's probably going to be found in the atmosphere where it's not quite as hot as it would be on the surface. So Ralph is asking, yes, for the organisms on Earth, we know our limits, but what about other planets? So, yeah, do you think that there are some organisms that we haven't discovered yet that might surpass the limits we know of? I I think that could be very possible, that there could be life on other planets that have limitations that go beyond ours. I also think that there's a better chance that life could be found on some of the moons of some of these planets, like, for example, Enceladus and Titan and Europa, because they have liquid water, they have oceans, they have some type of heating to heat up those oceans. And so I think that anything can be possible. And I guess maybe that question could be getting to the is my feelings about, is there life out there in the universe? And I'm speaking for myself. I'm not speaking on the behalf of NASA at this moment. And my sense is that, yeah, I think there's got to be something out there somewhere. Yeah, and I'm hoping that in my lifetime, I get to hear that some space agency, be it NASA or ESA or I don't care who it is, that they have discovered life. And to me, it doesn't matter if it's intelligent life or microbial life, that life has been discovered somewhere. And I think that's really going to be the biggest news that we human beings have ever gotten, ever. It's going to be incredible news. All right, where did Mars get its rust? So the rust comes from the minerals. What did I say earlier? Iron oxide. Okay, that's what we're looking at on Mars, which is basically rust. All right, that's on the surface of the planet. All right. Any other questions? All right, so I do know that I went over which planet rains diamonds. I believe that is, I'm pretty sure that's Venus. I'm not 100% on that, but I'm pretty sure that it's Venus, that it rains diamonds. All right. Well, I apologize for going over our hour, but I hope that you enjoyed tonight's presentation. I do want to remind you very quickly. Oh, I didn't even get a chance to talk about the exoplanets. So you're going to have to come back and see me in another program. A little joke here. Not going to have time to talk about exoplanets. But don't forget to subscribe to my channel, please. I hope to see you back on October the 25th, and I will be talking about moons of our solar system. All right, so thank you so much for joining me, and I hope to see you back on Sunday, October 25th at 8 p.m. Eastern Time. Have a great rest of your evening.
Countless worlds, scattered throughout countless galaxies, challenge the notion that we are alone in the universe. Exoplanets are worlds that exist outside of our solar system. Also known as extrasolar planets, these bodies often orbit their own stars, with some being a part of entire planetary systems. Exoplanets are made of the same elements as the worlds in our solar system, and based on their composition and structures, are just as diverse. Some, known as giant or Neptune-like planets, are large gaseous worlds. Other gas giants, called hot Jupiters, closely orbit their stars, causing the planets to have high surface temperatures. Another category of exoplanets consists of super-Earths. Smaller than the gas giants, but larger than Earth, super-Earths are terrestrial and made primarily of rocky or icy material. The final category includes Earth analogs. Much as their name implies, Earth analogs are similar to Earth in various ways, including size, composition, and distance to their home star. Exoplanets are difficult to detect directly, mostly because they are outshined by the stars they orbit. To circumvent this, about 5 primary methods have been developed to find these planetary bodies, including radial velocity, in which a planet causes a star to wobble; direct imaging, where the glare of stars is blocked in order to see objects nearby; astrometry, which observes a star's movements in relation to nearby stars; gravitational microlensing, which observes the light of a star being bent by a planet's gravitational pull; and the most prolific form of finding exoplanets, transit, the method in which a planet passes between its star and Earth, thereby dimming its star's light. Scientists have suspected the existence of worlds outside of our solar system for thousands of years, but the first confirmed existence of an exoplanet orbiting a sun-like star only occurred in 1995. Ever since, about 4,000 exoplanets have been confirmed by multiple discovery methods, with about 3,000 more awaiting verification. According to one theory, at least one exoplanet orbits each star in the Milky Way. This would place the exoplanet count in our local galaxy to about 1 trillion. The search for exoplanets continues, not just to create a catalog of known worlds, but also to see if life may exist elsewhere in the universe. Astrobiologists closely study the size, composition, and location of exoplanets relative to their stars to see the likelihood of organisms thriving in an environment other than Earth. Who knows what discoveries these new worlds could bring?